All right, the topic today is implicit differentiation. So consider the curve given by the equation y to the third minus xy equals 2. It can be shown that dy dx is equal to this. A, write an equation for the line tangent to the curve at the point negative 1, 1. We have negative 1, 1, and we need the slope. And so we need dy dx evaluated at negative 1, 1. And that's going to be equal to 1 over 3 times 1 minus, actually plus 1, because it's minus negative 1. So 1/4. 1/4. Y minus 1 is equal to 1/4 times x plus 1. That's a 1. All right, yeah, just write the equation. So I think we got it. B. Find the coordinates of all points on the curve at which the line tangent to the curve that at that point is vertical. Find the coordinates of all points on the curve at which the line tangent to the curve is vertical. So we want 3y squared minus x to be 0, because that's when we have vertical tangent lines, when the denominator is 0. And then we can use this to solve for the variables, because we have 3y squared is equal to x. So x is the same as 3y squared. So let's grab this one, and we're going to plug in 3y squared for the x. So y to the third minus 3y squared times y is equal to 2. So y to the third minus 3y to the third is equal to 2. Negative 2y to the third is equal to 2. So y to the third is equal to negative 1. So y is equal to negative 1. Find the coordinates. Well, y is negative 1. Let's plug negative 1 in for y. So we get negative 1 to the third minus x times negative 1 is equal to 2. So negative 1 plus x is equal to 2. X is equal to 3. So we have the point 3 negative 1, actually. 3 negative 1. Let's take a look at how we're doing here. Yep, 3 negative 1. All right, and then we got the equation there. Looking good. C, evaluate the second derivative at the point on the curve where x is negative 1 and y is 1. So d2y over dx2 is equal to bottom times the derivative of the top, which is 1, but then dy dx, minus the top times the derivative of the bottom. That's going to be 6y dy dx minus 1. And then that's all over the bottom squared. Now let's do this. Let's evaluate the first derivative at, negative 1, 1. And so if we plug 1 in, we get 1 over 3 times 1 squared, plus 1 because it's minus negative 1. So that's 4, 1/4. So dy dx, this is going to be 1/4, that's going to be 1/4. So let's evaluate the second derivative at the point negative 1, 1. So 3 times 1, that's going to be 3, plus 1 times 1/4, minus 1 times 6 times 1 times 1/4, minus 1, all over 3 plus 1 squared. So let's see what we get here. 1/4 of 4 is 1, minus, let's see, that's going to be 3 halves. 3 halves minus 2 halves is 1/2, so minus 1/2 over 16. That's going to be 1 minus 1/2 is a half over 16, 1 over 32. And I think that's it. Let's see if we got 1 over 32. Yeah, I mean, if that's the answer. There it is. So 2 for the implicit differentiation, 1 for substitution for dy dx, and then 1 for the answer. And you can see that they substituted in 1/4 for dy dx. Consider the closed curve in the xy plane given by that equation. Show that the derivative is all of that. So A, 2x plus 2 plus 4y to the third dy dx plus 4 dy dx is equal to 0. So let's factor out a dy dx. 4y to the third plus 4 is equal to negative 2x minus 2. So we'll minus those over. And then we have to divide. So negative 2 times x plus 1. We can factor out a negative 2 over, and we can factor out a 4. So we have y to the third plus 1, and we're going to get the version that they want. Negative x plus 1 over 2 times y to the third plus 1. B, write an equation for the line tangent to the curve at the point negative 2, 1. All right, we need a point and a slope. So we're going to evaluate dy dx at negative 2, 1. And that's going to be negative 2 plus 1 over 2 times 1 to the third plus 1. That's going to be 1/4. So 1/4. Just write the equation. That's it. All right. Y minus 1 is equal to 1/4 times x plus 2. Letter C. How about down here? Letter C. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. All right. Well, we want y to the third plus 1 is equal to 0. So that means y to the third is equal to negative 1. So y is equal to negative 1. Okay. Now let's just plug that into the equation. X squared plus 2x. X squared plus 2x plus 1, plus really negative 1 to the fourth, but that's going to be plus 1, minus 4 is equal to 5. So x squared plus 2x minus 3 is equal to 5. X squared plus 2x minus 8 is equal to 0. So x plus 4 and x minus 2. So x is equal to negative 4, x is equal to 2. So we have the points negative 4, negative 1, and 2, negative 1. Letter D. Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? So in order to have a horizontal tangent, this x plus 1 on the top of the derivative up there, that has to equal 0. So x has to equal negative 1, and y would have to be 0 in order to cross the x-axis. So let's plug the point negative 1, 0 into the original equation. So 1 minus 2 plus 0 has to equal 5. And negative 1 does not equal 5. So is it possible for the curve to have a horizontal tangent? No. And that's the reasoning. Negative 1 does not equal 5. So 1 for implicit differentiation, 1 for the verification, 1 for the slope, 1 for the tangent line, 1 for y is negative 1, substitutes y equals negative 1 into the equation of the curve, and then 1 for the answer. 1 works with x equals negative 1 or y equals 0 and answer with a reason. Write the first 4 non-zero terms for sine, cosine, and e to the x. So sine of x, sine is odd. So x over 1 factorial minus x to the third over 3 plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial. Cosine is, did I say sine is even? Sine's odd. Cosine's even. So 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, x to the sixth over 6 factorial, e to the x, well, e to the 0 is 1, and then all the derivatives are e to the 0. So they're all 1. So 1 plus x squared over 2 factorial plus x to the third over 3 factorial. Find dy dx and the second derivative if we have this here. All right, so dy dx is equal to 2t cosine of t squared over the derivative of x is 6t. So that's, let's go with cosine of t squared over 3. So 1/3 of this. So now the second derivative is, that's 1/3 of, so 2/3 t negative sine of t squared. But here's the trick, and here's why I picked this one. You have to divide by dx dt again, so over 6t. So, I mean, you could have negative 2 over 18 sine of t squared, and if this was multiple choice, we'd have 1/9 sine of t squared.